Hi there, this is a video about inverse functions. Now, the word inverse is kind of like the word reverse. And what I often like to think about is like the opposite. All right, so like when we think of the word inverse, like the inverse of addition is subtraction, okay? The inverse of multiplication is division. And I like to just think of those as opposite operations, okay? When we're talking about inverse functions, though, as a whole thing, it's a function that reverses another function, okay? And so basically, when we talk about inverse functions, the thing that pops out in my head is that you do the following, is that you switch x and y and solve for y, okay? The big thing to get here is that you switch x and y, all right? That's the main concept when dealing with inverse functions, okay? Now, before we start determining what inverse functions are, what we want to do is work on some notation. So when we have a function, f of x, what we know is that the inverse, all right, is labeled as such, as f inverse of x, all right? So when you see something where you have a -1 exponent in front of your function, that means you have the inverse, all right? So I'll talk more about that once we actually look at a function itself. So let's say that we have some function we'll call f of x that is created from a series of points. And let's say that those points are -2, 1, -1, 0, and 0, 3. Now, if I wanted to calculate my inverse function of x given a set of points, then all I would simply do is switch my x and y value for each point. All right, so you've got the point 1 comma -2 here. You'd have the point 0 comma -1, and then you'd have the point 3 comma 0. All right, and that would be the inverse. Let's look at a graph of this function. So if I graph my function f of x here in red, let's graph the point -2, 1, -1, 0, and the point 0, 3. Now, if I graph our inverse, f inverse of x, let's do that. We've got the point 1, -2, 0, -1, and then you have the point 3, 0. Okay? Notice that these lines they look like they're all just reflected over a certain line, and that certain line that they're reflected over is the line y equals x. Okay? So y equals x is a line of reflection that you will see throughout this video. Okay, and that's just a line with a slope of 1 with a y-intercept of 0. Now, the other kind of way that we could determine inverse functions is by calculating them algebraically. So what I want to do is look at this function g of x. Let's say that g of x is equal to 5x plus 2. All right, and if I wanted to calculate g inverse of x, then we do the following. And that's going to be switch x and y and solve for y. So the first thing I want to do is rewrite this. Instead of writing g of x, I'm going to write this as y equals 5x plus 2. Now, that's the first step, all right? Then I want to switch x and y. So then we're going to write x equals 5y plus 2. The next thing you want to do is solve this equation for y. So we're going to subtract 2 from both sides, and that's going to get x minus 2 is equal to 5y. Now then, the next thing we want to do is divide both sides of this equation by 5 to isolate y. The 5's divide out here, and you're left with y equals x minus 2 all over 5. Okay, and then what we want to do is this is our inverse function. Okay, we've solved for y. We want to write this in inverse function notation. So I'm then going to say that our new y value here that we've solved for is now our inverse function, g inverse of x, and that's equal to x minus 2 all over 5. This is our new inverse function. Now, if we look at a graph of these two, all right, notice that our blue graph right here is our original function g of x, and that our inverse function is our red graph g inverse of x, okay? And you can look at various points here. Like if you look at the point, say 0, 2 on our our function, notice how you have the point 2, 0 on your inverse, okay? And those are simply just reflected across the line y equals x, okay? So that's what an inverse is, okay? Now it's important that we also look at inverses and say, all right, I have this line here, and this is my function, all right? We've established that it's a function, and then notice how the inverse is also a function, okay? For every x value, there's exactly one y value. Now this isn't always the case, okay? So it's important that you're able to look at the graphs of these functions and know whether or not the inverse is also a function. That's all I have for this video. Thanks a lot. Bye.